Welcome back. Let's talk about congruent polygons. Congruent polygons are polygons that have congruent corresponding parts. Now, what this means is you can have more than just angles congruent or segments congruent, but you can have whole shapes that are congruent to one another. But that means that they're going to have parts that match up in size. That information can be given to you in several ways. One way is like we see here in a diagram. And in the diagram you have all the parts that match up marked in the same way. For example, angle C has an arc with one hatch mark on it. Angle J has an arc with one hatch mark on it. So those two parts correspond or match. They're the same size. You can do the same thing with your segments. Segment CE has one hatch mark on it, and segment JL has one hatch mark on it. So they correspond, and they're the same size. Well, that information can be given, as you see here in a diagram. It can also be given in a list. You can match up the parts in pairs. So you can say something like this. Angle C is congruent to angle J. You can say the second pair, angle A is congruent to angle N, and then thirdly, angle E is congruent to angle L. Now you can do the same thing with your segments. As we said before, segment CE will have a match with segment JL. So these are matching parts, or we call those corresponding parts. Segment AE is congruent to segment LN, and the order of these letters and the names of the segments doesn't matter. LN or NL still means the same thing. Segment AC is congruent to segment JN. So we have a diagram, we have a list, and then we can also have something called a congruence statement. Now, the congruence statement is a symbolic way of stating the relationship between two congruent polygons and their corresponding parts. So because of that, the order matters. The order is of critical importance. The order is going to matter. Now, here's how we do that. When we write it, you're going to have the name of one of your triangles on one side and the name of your second triangle on the other side. But when you write the first one, you can write it any way that you want to. For example, if I choose to write this one as CAE, that's up to me. But when I write the second one, I have to do it in a particular way now. When I went from C to A to E, if I think of it in terms of the angles, I went from the angle with 1 mark to the angle with 2 marks to the angle with 3 marks. When I name this one, I'm going to have to follow that same order. 1 mark, 2 marks, 3 marks. That's J, N, L. Now there are other options on how I can write the congruent statement, but once I choose the first one, the order of that forces how I have to write the second one. Now you can also follow along the sides and see how their markings are, and then duplicate that same order on the other one. So angles or sides will work for that. Now these two triangles are completely separate. So your diagram, they look separate. Your list, they're completely separate here. They're all the angles are listed with one letter for their names. The congruent statement, they don't have any repeated letters. But when you look at this second example, now these two triangles do share something. They meet at this point right here. And so the diagram is given but our list is going to be affected. We have 3 angles and we have 3 sides that we have to pair up. Let's do the sides first on this one. We have ST and WT. We have RT and TU. And we have RS and WU. That one's done just the same as we did in example number 1. Now the angles are a little different. We have angle R and angle U with the same marking. We have angle S and angle W. But when we get to our third one, we notice that there's more than one angle at T, so we're going to have to use 3 letters to name these angles. And we know these are the same because they're vertical, even though they were not marked as congruent. We can do that now. So angle STR and angle UTW. They're congruent. Our congruent statement will also be affected since one letter is, this point is in both triangles. Our congruent statement will have one letter that's repeated. So when I name the triangle on the left, let's say RST. When I name the triangle on the right, I have to follow that order, and I will notice that a letter gets repeated. I went from the angle with 1 mark to 2 to 3. If I go 1, 2, 3 over here, that's U, W, T. We have a repeated letter. Which means we have in the diagram itself a shared vertex. So even if I don't have a diagram, but I have a congruent statement with one repeated letter, I would expect it to look something like this. Our final example has 2 triangles and they share a side. Some of the marking has been done for us. I know that these 2 sides are the same, these 2 sides are the same. This side is shared, so it would also be the same. There's also a theorem that I didn't mention at the beginning called the third angles theorem. And because we know the total of all the angles in a triangle have to be 180 degrees, if I know 2 of the angles, like I do here, 2 of the angles correspond, then I know the third angle would have to correspond as well. So I'm going to go ahead and mark that. Now everything's marked. The diagram is complete. Let's go ahead and create the list. Our list will be affected again, just like it was before. Angle G is congruent to angle P. When I come to this angle, there's more than one angle here at H, so I'll need to use 3 letters. I'll have to do the same thing down here when I name these. So angle GHM is congruent to angle PHM, and angle GMH is congruent to angle PMH. So this side is where they meet. It has 2 endpoints. Those letters are getting involved here. We'll see that show up in our segments, but we also end up having 2 pairs where 3 letters were necessary to name those angles. If we look at the segments, GH is congruent to PH. GM is congruent to PM. And then kind of in a strange way, this is going to be in both. Let me explain what's going on there. the HM that's part of the triangle on the left is the same size and same measure of the HM that's on the triangle on the right. And that's because it's the actual same segment. But we do have to make that statement here in the list. Our congruent statement will now have two letters repeated. GHM went 1, 2, 3 on the angles. Over here, that's PHM. HM is repeated. Two letters. It means we have a shared side for our congruent statement here. It shows that. See you next time.